Welcome everyone to this continuation of PTV Talks. This particular webinar, as you have already heard, is about PTV Flows, which is our cloud-based traffic monitoring system. The context of this webinar will be surrounded by traffic and congestion situational awareness. In this webinar, we will talk about, of course, PTV Flows, talk a little bit about what it is, and we will have a demo at the end of this presentation also. We'll talk about floating car data, FCD, in terms of real time and its real-time applications. We'll also talk about the benefits of turnkey solutions. And in this context, we're of course referring to turnkey solutions or SaaS solutions versus hardware. And then we'll talk about some use cases, jump into the platform, and of course have some time at the end for your guys' questions. So PTV Flows. PTV Flows is our cloud-based real-time traffic monitoring system, as I mentioned before. It is an interface backed by floating car data. TomTom is our provider, and I'll talk to TomTom in a little bit here. It provides a collaborative environment to monitor the state of the network of whichever region that you are interested in for your particular project. It offers custom KPIs to monitor specific links and roadway networks that are most relevant to you. It has state of the network analysis on recent trends so that you can look at temporal and spatial trends in terms of vehicle speeds and travel times. And then, of course, it has a machine learning based traffic forecasting, which is an exciting feature on the platform that allows you to see up to 60 minutes ahead. That's based on historical trends also. So some of the features of PTV Flows, which we'll get into and talk to a little bit further in this presentation. Of course, it is cloud-based, so that means automatic activation and updates. It has a native integration of some standard data, that being the floating car data that I mentioned before, and of course the maps that come associated with the platform. It is accessible via the graphic user interface that you log into with your myptv.com account. And we also offer API integration that neatly ties into your existing systems. I mentioned the KPIs before, that you can highlight certain corridors, and with these KPIs you can actually share and create a sharing system of alerts via email or Twitter, now known as X, in which you can share estimated travel times or changes to the congestion rates of your road network to whatever audience that you feel should be in that loop. I mentioned the self-learning traffic forecasting, and some features coming soon are some, we'll get a little bit more granular with our probe density. So we'll have some more information on that coming to the platform in terms of the probe density per region. And then of course our historical analysis feature. At this current time, we can jump back 24 hours into the platform, but soon to be coming to the platform is a little bit more of an extended glimpse back into historical analysis and trends as the platform has been running. The floating car data in real time. It's been around for a little while now. Most people may know it as just a big data solution that you can obtain if you're looking for some sort of situational awareness or insight into a road network or region. Typically, it offers a more cheaper and a more efficient way to monitor this traffic and congestion versus your traditional hardware sensors like Bluetooth or cameras. It requires less on-premise infrastructure, of course, in comparison to hardware, less maintenance and operation, and has a quicker lead time to deployment. However, some of the major concerns that we hear when talking about floating car data, specifically in a real-time application is, well, if we're just purchasing a large batch of data, do we have any sort of interface to be able to manipulate and work with this data? Is there any flexibility and scale and customization into the data that we're getting? Can we go a little bit more granular on a link by link basis or a certain roadway network? So these are some of the major concerns. And then finally, probably the most talked about one is the subject around latency. When we're comparing versus hardware, floating car data can often seem like it is a little bit more less real time. And in this presentation, I'm here to offer some evidence to the contrary. So when selecting our floating car data provider and our partner for this platform, PTV Flows, we were very meticulous with our selection. We didn't want to have a data provider that put unreliable or inaccurate data into it. We wanted to make sure that the end user and customer of this PTV Flows platform was getting the most optimal, most real-time data possible. And so that's why we selected TomTom as a worldwide provider for PTV Flows. They, of course, have 600+ million devices worldwide in 81 countries, with over 61 billion data points processed daily. That data is updated every 30 seconds. So all that means is that we're getting a streamlined and reliable flow of data into our platform that results in about 15 to 25% penetration rates in key areas such as densely populated metropolitan areas. This is a metric that really stood out to us, particularly in comparing to other providers, as penetration rate is ultimately what stands the test of time when it comes to floating car data. I mentioned latency, and when selecting our floating car data provider partner, when talking about PTV Flows, we needed some really solid evidence and backing up that TomTom could stand that trial. So we got that. Actually, the Eastern Transportation Coalition put together a probe project in which they analyzed 3 FCD data suppliers and wanted to test their latency rates. So you'll see here in this image on the right, this is one such instance in which they did multiple, of course, but this particular one I have displayed here. TomTom is, of course, vendor C, so keep an eye on that orange yellow line there. But essentially they introduced, well, there was a slowdown on a roadway network. And so they analyzed the probe data coming from 3 different vendors, and they showed that vendor C was the quickest to react to this slowdown on the roadway network and proved the least amount of latency. So this particular example and overall this entire study and multiple other studies proved to us that in terms of latency, TomTom was the route to go, and we're happy with having that reliability on our platform. And now we're talking about turnkey versus hardware. So this is really, the question is, we've got a legacy system of hardware surrounding all of our municipalities and regions in this country and in countries neighboring us too. So the question becomes, is there room for turnkey? What are the benefits and how can it stand up to the existing comfortability and benefits that we have with existing hardware systems such as Bluetooth sensors and cameras? And the first metric that we want to talk about when juxtaposing turnkey and SaaS solutions versus hardware is time efficiency. So when we're imagining deploying a citywide hardware installation, in terms of timeline, we're looking at months. And this is, usually it is variable depending on certain barriers. And some of these barriers are permits and approvals. This particular one can be the most straining on our project timeline, but we also have site preparation and weather conditions, technical complexions, and contractor availability. So these are some of the metrics that when we're looking at a particular project timeline, these are going to be some of the things that really draw out, our budget for time. Now juxtapose that to, for example, PTV flows, creating a citywide network and getting that situational awareness is instantaneous. And just, once that application is up and running, which that process alone just takes a couple of hours, we get the data immediately. So now our timeline goes from a few months or more to just a couple of hours. The next metric, of course, time and money, and now we're talking about cost efficiency. So when in the traditional hardware environment, there are a plethora of costs associated with installing a hardware system. And these are, of course, the initial unit and purchase of our hardware systems, and then installing them. This, of course, includes labor costs associated with that. Once we have our hardware system up and running, there's going to be maintenance and operations. And then once our network is up and running, of course, we have to begin to put thought towards this data transmission and storage. We've got a rather complex network going, and that takes some pretty large storage on typically the user's end. And then if we want to, expand this already existing rather complex network, that's going to add on to our budget and increase our cost. So the scaling feature becomes a little bit more difficult and a little bit more cost efficient. And then, of course, we have our bureaucratic barriers with licensing and permits, and these can typically be associated with the most time draining on our timeline, but also can attribute significant costs to our project. And then finally, energy consumption too. So juxtapose this again to turnkey solutions. We already talked about the time, so that's saving you money just there alone. But of course, there's zero maintenance and zero operational costs. So essentially, most of these SaaS operations and programs have a subscription-based platform. So you're looking at one cost per year, and that's that. There's no operational costs, there's no maintenance, there's no variables like weather conditions that can interfere with your system. So the costs becomes rather simple. And then scalability and flexibility. And I think this is a pretty important one when we're talking about SaaS solutions. I think this is really where it stands out. So here I'd like to just talk about really the benefits, looking at, for example, PTV flows as a scalable and flexible solution. Primarily, the first thing that usually sticks out to people is the cross-jurisdictional feedback. So right as our application is up and running, or as we're building our geographic region that we want to study, we notice that we don't need permits, and we don't need any sort of municipality permission to kind of cross these jurisdictional borders. So in this example on the right, we can build an instance that crosses from Portland to Vancouver. And as we all know, traffic that is existing in Vancouver affects traffic that exists in Portland. So being able to cross these jurisdictional borders with little to no obstacles is extremely important. We also have a total customization over our road network size. So you'll see here on the right, this is actually a glimpse from our instance configurator, which is how we generate our PTV flows instances in our geographic regions. And you see that we have a tier system from 0 to 8. So if you're particularly concerned with just one particular roadway network, maybe it's a major motorway, maybe it's an arterial road, then you can select just that particular road and get extreme customizable data that is, going to make the project a little bit easier to study, because you don't have to consider all this external data that's just going to add more burden. But of course, if you want to go a little bit more granular and microscopic, then you can, of course, select roads all the way down to local unimportant roads, neighborhood roads, connecting roads. So it's this customizability that really stands out. There is rapid application relocation. So essentially what that means is if you've set up here in Portland and Vancouver and you've created the shape of the geographic region that you want to study, and maybe over time you're less concerned with downtown Vancouver or some of the neighborhoods and regions in Vancouver. Well, it's a simple process as it is simple to create this geographic region to also adjust it. So we can then cut down on that size and maybe just look to the border regions of Vancouver. And of course, I mentioned this before, but the ability to not only adjust our geographic region, but again, there is no downtime when we're moving these regions or adjusting our size or even our roadway networks. You're getting that instantaneous network feedback throughout the entire process. With remote application access with the internet, that means that you have the flexibility to access the state of the network and access these traffic forecasts and these KPIs as long as you have access to the internet, which provides a lot of flexibility to your team and your user base. And of course, with project length subscription, that means that you can essentially monitor your network for as long as it is important to you. So compare that to a hardware type environment. You're going through a lot of time and money and a large process to set up a perspective over the traffic network. And if this is just a simple 1 to 2 year or even less project, then that's quite a lot of effort for such a small timeline. So having the ability to just monitor the traffic congestion and traffic data that you need for the timeline that you need is also vastly important. And so now we'll talk about integration and accessibility, another metric in which we're comparing our turnkey and SaaS solutions to our hardware network. So in the hardware and data integration environment, it can be a challenge to sort of have one central perspective on our data flow. So when we look at things like system compatibility with all of our different hardware systems, some of these, of course, being proprietary systems, which can be cumbersome to navigate. And then we have inconsistent data formats coming from the variety of our different sources. Some of these take specialized individuals to know, the technical knowledge to be able to not only work with this data, but the infrastructure itself. So creating this complex network infrastructure can also often create more costs and more time loss in the future, but also just adds to the complexity of the project. And then obviously the most clear difference between a SaaS solution and a hardware solution would be that most often than not, with a hardware environment, you're going to have to be on an on-site premise to be able to access that information reliably, as opposed to having remote access with a simple internet connection. So with PTV flows, with this API, we approach the integration challenge quite simply as you can get this data fed from the PTV flows platform straight into your existing and native systems with a very simple process. Multiple users can access the same platform anywhere in the world, adding much more flexibility and accessibility to your team. And a simple user interface means that there is little to no education necessary and no downtime when considering particular projects and educating your team for that process. And of course, the native features and capabilities that come with a SaaS solution, and I'm going to talk about just a couple here, just to kind of get you guys ready for the demo here. I won't spend too much time on these because I'd like to actually jump into the platform and showcase them to you. But with these custom KPIs that I've mentioned, you get to monitor key road links and throughout your network, and specifically monitor different variables like vehicle speeds. And I mentioned the sharing system, but it's a simple process. Once you have built your custom KPI, whether it be a particular construction site that you are monitoring congestion on, or whether it's an arterial road that you want to monitor congestion rates that feed into a major highway, it's simply just inputting a list of emails or creating the connection to X or Twitter. And this allows you the ability to communicate to whichever audience that you find necessary, whether it be actual road travelers, people on the roads, or whether it be your team members. So it provides a lot of flexibility on that front. And we have an internal native analysis system within the platform too. So as the instance is running, as you're monitoring your network, you can actually jump in real time and just see the past 24 hours and actually extrapolate this data too via a CSV file. So you can look at different variables and different trends, and I will showcase those in the platform here shortly too. But this one we have here listed on the right is, of course, expected travel time over time. So we get to see those peak congestion rates often associated with, key moments in whether it be a special event going on downtown or it be rush hour for commuter traffic. And then traffic forecasts. So we have a machine learning algorithm that is consistently learning in the background, studying the roadway network. And it will monitor these different trends associated with different times of the day, which means that you can jump 60 minutes ahead into the future and be able to actually visualize on the roadway network what these expected trends can look like. So this is a near-term traffic forecast. Typically, the longer the platform is up and running, the more accurate it's going to be. So having that platform continually learn and adapt to the different trends is key. All right, now we'll talk about some use cases. So we have our traditional highway network, of course, monitoring just our congestion rates and our travel times, that we can then communicate this information to our traffic response teams, our road authorities, but also, implement our predictive congestion alerts to, actually engage with our network and perform some traffic rerouting or activation of reserved lanes or express lanes. So this gives us a real-time perspective on our network with a low amount of investment in which we can actually start to affect and change our traffic flow and congestion rates. Of course, it fits nicely into the TMC Center also. So with that API integration, you can have that data flow right into your existing systems. Use it as a complementary tool. If you have an extensive and complex hardware network already set up, we certainly wouldn't want to replace that, but we would like to add some situational awareness that you can use to support your TMC Center and your team. For construction site monitoring, it's actually a really good use case with PTV flows. So we can select the key links around a construction site and monitor the expected travel times and the congestion rates along, before, and after that point in the network where there is road work going on. And of course, our pre and post studies. So if we're actually doing some sort of intervention or road work or even signal timings, if we're doing some work around an intersection, we can create a flows environment that monitors the congestion rates and travel times before, during, and after the actual intervention on the roadway network. It's also a great use case talking about events and transportation hubs. So when we're looking at a particularly busy airport, or if we have a special event coming to our city or our region, whether it be a marathon or even the World Cup games coming up, something like that, then we can have the ability to rapidly deploy a geographic region and get immediate real-time data feedback to us. And when we're talking about events, that can happen as quickly as just a few days before the actual event takes place. And of course, floating card data supply and compliance, oftentimes when we're looking into short-term and long-term projects, floating card data can be, a part of that project that is becoming something that, municipalities and organizations want to see. They'd like to see that data backed up on any sort of project done. And of course, you can have that delivered to you via API, or just have the network up and running while you're working on the project. And we will move on and jump into the platform here. So allow me to pull up PTV flows. And what you're seeing, of course, is a nice greeting from PTV flows to me, but you're seeing a bunch of inputs here. So you'll see API keys on the bottom left. So that's where you'll access your API keys if you need multiple, or if you have a number of different systems tying into PTV flows. You'll see your user management here in the top right. That's where you can jump into the platform, monitor the users, and actually apply certain rights, whether they are just users or supervisors on the platform too. So again, this is a very collaborative environment for you and your team. We also have our Help Center support and contact sales. Our Help Center has a fantastic resource for documentation, tutorials, and all sorts for educational purposes that allow you to really dive deep into the platform and understand all the features and functionality behind it. And of course, support, you can access any of our support team members at any time, and we'd be happy to jump in and help guide you through the process. But of course, where the magic happens is behind the PTV flows supervisor. And so I've got an instance running up here for you guys, and it is, of course, Atlanta, Georgia. So it's a rather large instance that we have here. And I did this just to kind of add some flexibility to this particular demonstration. So we can see that we have a number of arterial roads and highways that feed into downtown Atlanta. And that gives us the flexibility to monitor a number of different use cases. So I have some highlighted here, and I'll talk about those in just a second here. But if you look on the left, you'll see some notification bars that are critical, warning, and normal. So these, of course, are how we determine whether you get an alert. So we have our highlighted KPIs that have been drawn on the network here. And if any of these KPIs, if the travel time exceeds a certain limit, if we see a large increase in our travel time, then it will send a warning alert. If those travel times increase even further, we'll see a critical alert. So on a real-time basis, you can understand, what's going on this particular section, whether it be a construction site or whether it be a particular event going on. We can understand exactly what degree of congestion are we seeing at this particular location. So let's zoom in onto some of these KPIs, and we'll select this one for the first example. And this is an example of actually an arterial road. This is Buford Highway, US 13, that actually runs alongside, I believe this is I-85, that's it, I-85 South, directly into downtown Atlanta. So as we're monitoring this arterial road, you can imagine that this might be an integrated corridor management study, or perhaps we're just looking for some situational awareness into this road that runs alongside a major highway. So you'll see here we have a current value of our expected travel time. So that means from the beginning of our KPI to the end, that is our expected travel time along that route. That's compared to our free flow value, which is just a simple metric based on actual speed limit and distance. So it's a pretty simple equation. Coming soon to the application in the product roadmap, we're actually looking to add a little bit more of a dynamic free flow value, or just a standard number to compare our current value to our expected travel time. So maybe this is one that's based on historical trends as opposed to speed limit and just a speed calculation. So we have our KPI type, expected travel time. We have a trigger type, which is our free flow. And that's where I'm talking about how we're bringing in some new trigger types coming soon. We have our name of our KPI, and these are the parameters in which determine what is a critical, what is a warning, and what is a normal state of this KPI. So you'll see here, if we're 140% above our free flow value, then that's when we're going to get a warning alert. If we're 180%, that's where we're going to get a critical alert. All right, and then let's jump into some of the analysis features for this particular KPI. And this particular graph will look familiar. That's what we had in the presentation just moments ago. This is expected travel time over time. So you'll see that we had a peak in expected travel time around this time here. And you can actually see the figures, and if we hover over the map, we can see the expected travel time and the time of the day. This, of course, is all exportable via a CSV file, as are each of these graphs. Our second analysis is going to be expected travel time along the route over time. So this is where we get into a little bit of a temporal perspective and a spatial perspective. So we can see, based on this heat map, this is our path progression. So keep in mind, from the beginning of our KPI, where we've drawn on our roadmap is at the bottom, and at the top is the end of our KPI. So we can see that as we get towards the end of our KPI that we've drawn, this is where we're starting to see more of the congestion. And at what points of the day? Well, we can just look down at the bottom and look at our x-axis for the time of the day, the actual date. And then finally, we see the correlation between the two. It's a ratio between expected and free flow travel time for each section over the route over time. So this is where we kind of blend in the temporal and spatial a little bit more further, and actually, look at path progression and then the ratio of the two over time. All right, back to our map. So that's an example of an arterial KPI, and we actually have one more KPI down here, which is just an example of a congestion study for construction. A construction study. So we have actually an ongoing construction project. I believe it's down here just by this link. So we drew a KPI going southwest out of Atlanta, feeding into this construction site. So if we click on this, we'll notice as we jump into our analysis that if we go down to the spatial, we're starting to see some of that construction right about the 2 kilometer mark. So this is obviously where the construction is happening, but we can actually see, well, our construction at this time of the day is actually creeping up all the way back here. So we get a really great perspective over exactly where our congestion and our increase in travel time is happening along our route. So drawing these KPIs is a very simple process that I'll just demonstrate quickly here. We'll select this particular road here. We're going to click on the pencil marker here. And then we're just going to select. and draw. And then once we've reached our location, which will be right here, just double clicking. Very simple process. We can give it a name, select our KPI type, our free flow trigger, and then give it a name, and then set our parameters, and we're good to go. Finally, I mentioned and have specifically left the traffic forecast towards the end here. This is one of our most exciting features here. So if we just take a glimpse into our roadway network, we'll notice kind of where we're at. We'll zoom in actually on a particular busy intersection. And as we adjust our traffic forecast here, we'll start to see that the roadway network changes on a live basis. So if we're jumping 30, 40, even 50 and 60 minutes into the future, we can actually see, based on historical trends and our machine learning algorithm, what the state of the network will look like in 60 minutes. And on the product roadmap is to actually expand from 60 minutes all the way up to 120. So soon we'll be able to get a glimpse 2 hours into the future. All right, that is a short demo of the platform. I'd like to take this time just to remind you all that we do absolutely love to invite potential users or anyone who's interested to join for a free trial. This is a really great and new innovative platform that we love to get feedback on. So if you have any curiosities and you want to try it out or even test the data for yourself, please don't hesitate to reach out to us.